Okay, Bio30 is lesson 2 in chapter 21. Focus question for today. All right, in what ways can allele frequencies in a population change over time? So there's many ways that allele frequencies can change over time. One way that we learned last year, I guess in Bio20 or last semester for some of you, would be natural selection. And here's a great example of natural selection where we see the African savanna elephant versus the African forest elephant. Let me just grab my pointer here. So forest, savanna, obviously. So what are the pressures, right? Well, pressures. Trees are narrow. There's not a lot of room to walk. All right. And this elephant must be able to maneuver to avoid predators as well. So it's smaller, skinnier, compared to the African savanna elephant, which can grow as big as it wants, as space isn't an issue for it, and it will avoid predation better in the open where it can defend itself with its size. Whereas these elephants will most likely hide, avoid predation, although they're still rather large creatures. Regardless, we can see how even though these are not separate species yet, so speciation has not occurred, what does that mean? It means that this elephant and this elephant, being of opposite biological sex, can mate and have viable offspring. So remember Hardy-Weinberg, the 5 conditions for Hardy-Weinberg, right? Now, the 5 conditions for Hardy-Weinberg state that no evolution is possible in a population. Now, I explained this in your last lesson as a null hypothesis. It's just something we compare the real data to, all right? So this gives us a base, some base data by which to compare the actual population to. So what does change allele frequencies? Let's compare, for example. So population is infinitely large. Hardy-Weinberg principle states that, well, in a small population, chance fluctuations cause changes. This is known as genetic drift. So we're going to look at genetic drift in this lesson. Number 2, no migration. Okay, well, migrating individuals remove alleles from one population and add them to another. So again, this will change allele frequencies. Number 3, no mutations. Well, mutations occur all the time. Mutations can produce new alleles, as we studied in chapter 20 or 17. 20, it was 20. Number 4, going the wrong way again. No natural selection occurs. All right, well, natural selection can ensure that advantageous alleles are passed and disadvantageous alleles are not passed on. Those individuals will pass away, or they will not breed as frequently or not at all. And number 5. Okay, mating is random for Hardy-Weinberg, so this is opposite again. Preferred mates will pass on their alleles in greater frequency. So, preferred mates, this is known as sexual selection. So now we have 2 types of selection. New one added to you, natural selection, and this would be known as sexual selection. Now, as you go through all of these, right, small populations, genetic drift is number 1. I'm not going to go through the whole PowerPoint today. For this lesson, is not necessary to do that. All right, if you have questions regarding genetic drift, especially between understanding founder effect and the bottleneck effect, please ask. Okay, I can give a quick explanation of that. Okay, so that's genetic drift, small populations. That was number 1. Number 2 was migration. So we call this gene flow. Natural selection, 3. Mutation, 4. Here's a good example. Non-random mating, as I was talking about sexual selection, number 5. And so work through these, watch the videos, especially these two and this one. They're awesome. Okay, oh, and that's a stupid meme. Okay, so again, work through this PowerPoint. You post questions to the comments section of this lesson, and I will answer them as efficiently as I can. Alrighty then, here we go. Good luck, and we'll talk to you later.